Our galaxy is surrounded by a vast number of space objects that remain largely unexplored. However, among this diverse range of celestial bodies, the solar system holds a special place. It is the only known place in the universe where intelligent life could originate. To understand the factors that allowed this to happen, we must embark on a journey to the most fascinating component of our cosmic abode, Venus. At first glance, many space objects that are relatively close to Earth may seem harmless. However, upon closer examination, most of them lose their benign appearance. Unfortunately, science has yet to identify any places in space where humans could potentially survive without a spacesuit. In some locations, even heavily armored devices would be unable to withstand the extreme conditions. When we think of a real hell, images of erupting volcanoes, absolute darkness, lightning, and ash come to mind. Surprisingly, such a place already exists, a mere 38 million kilometers away from Earth at its closest approach. Venus, the closest planet to us in the solar system, harbors similar conditions, resembling a true inferno. To appreciate the disparity between our worlds, let's consider the Earth's atmosphere. It consists of 78% nitrogen, 21% oxygen, and 0.13% argon and carbon dioxide combined. Thanks to this composition, we can breathe freely without discomfort. In contrast, Venus' atmosphere is composed of 96% carbon dioxide alone. Upon arrival, a person would experience severe suffocation due to hypoxia with their first breath. Even if we were to overcome this problem on the surface of Venus, another challenge awaits: the incredibly high atmospheric pressure, which is roughly double that of Earth. Under such conditions, a person would feel as if constantly submerged 500 meters underwater. Adding to the harshness, the surface temperature can reach a scorching 462 degrees Celsius, completing the image of a real inferno. The study of Venus began in the 17th century when Galileo Galilei observed the planet with an optical telescope. In 1639, the English astronomer Jeremiah Horrocks witnessed the planet's phases, and on June 6, 1761, Mikhail Lomonosov observed the refraction of the sun's rays in Venus' atmosphere. The first images of the planet's surface were obtained in the late 20th century by the Soviet probes Venera 9 and Venera 10, which successfully landed on Venus on October 22 and 25, 1975. 7 years later, in 1982, Venera 13 and Venera 14 transmitted the first color images of the planet from its surface. Unfortunately, the probes sent to Venus could not provide a large number of detailed panoramic images, similar to the rovers on Mars. The conditions on Venus are so harsh that no spacecraft can survive on its surface for more than 2 hours. The rovers and landers transmitted information from a place where erupting volcanoes, lightning, and a dense cloud layer obscured the sun. The wind on Venus reaches speeds of 150 meters per second, and temperatures can soar to 480 degrees Celsius. Only 30 successful spacecraft launches have managed to transmit information about Venus, with the last soft landing occurring in November 1982. Why did we venture to such a hostile celestial body? For a long time, people believed that life on Venus was impossible. It receives twice as much solar radiation as Earth, making it consistently hot. However, in 2016, it was discovered that this perspective was not entirely accurate. Due to the planet's extremely long days, which last longer than its nights, it is theoretically possible for large liquid reservoirs to exist during the prolonged Venusian night, which lasts for 116 Earth days. Heat from the unilluminated side of the planet escapes into space, which would cause Venus to cool significantly if it weren't for its thick atmosphere. Despite the challenges, there is a possibility that someday we will be able to send an expedition to Venus with human occupants. Technological advancements could potentially overcome obstacles such as solar radiation. Creating an artificial magnetic field around the proposed station or interplanetary ships could solve this problem. However, due to the extreme temperatures and pressures on Venus, it is unlikely that people will be able to remain on its surface for extended periods. Instead, short-term descents from the cloud layer to the planet's surface, similar to deep-sea submersibles exploring the ocean depths, may be possible. This would require a large-scale airborne base that can hover above the surface and sustain itself using solar energy. Currently, these concepts represent the main approaches for exploring Venus. Another possibility is terraforming the planet, which involves artificially altering Venus' climate. This would require increasing the amount of water, decreasing temperature, and reducing the atmospheric pressure by at least 10 atmospheres. The initial stage of terraforming would involve bombarding the planet with icy asteroids to accelerate its rotation and generate a magnetic field. Subsequently, efforts would focus on lowering the temperature and mitigating the greenhouse effect by reducing the atmospheric carbon dioxide. Successfully completing this process would take centuries or even millennia. Despite the widespread interest among scientists, exploring Venus has taken a backseat in recent decades due to limited funding and a focus on Mars as a more accessible and intriguing target. According to current assumptions, the future Venera D project aims to have a lander survive on the surface of Venus for 3 hours, during which it would collect soil samples and transmit approximately 340 megabytes of information back to Earth. The Venus Globe project, which includes an orbiter, a long-lived station, aerostats, and probes, could be the next step in exploration. The study of this fascinating celestial object is unlikely to lose its relevance in the near future. Venus remains the third brightest point in our sky and marks the starting point of humanity's exploration of planets using space technology.